This session of lectures. So today's session we will see the limitation of pH scale. pH value of the solution, they do not give immediate idea of the relative strength of the solution. This is one of the limitation. So they do not give the immediate ideas. Likewise, see here. Suppose the any solution having pH 1, so concentration H plus is 10 to the minus 1, and there is another solution is which pH is 3 and concentration 10 to the minus 3. So by taking the value we can give the compare it. Means this is the 100 times more acidic than this. This is not the 3 times. Similarly, if you take this 4 into 10 power minus 1 normative HCl is twice concentrated of a 2 into 10 power minus 1 normative HCl solution. It's 0.2 normal solution and 0.4 normal solutions. But the value of pH of these solutions are 4.4 and 4.7. It's not a double. So it is not giving the immediate idea. So it is just this much value is there. This is one of the drawback. Second is that if you take the pH equal to 0 for one normal solution a strong acid, okay, so for one normal it is always considered as a 0. If the concentration is 2 normal, 3 normal, 10 normal, then respective pH will be negative. So this is another limitations. Third, if a acid solution which have very low concentration means the concentration of H plus is 10 to the minus 8 molarity or 10 to the minus 8 normality. So their pH is not actually 8, but actually pH is less than 7 or close to 7. So in these cases, when the concentration of H plus is greater than 10 to the minus 6, we will use the general formula, that is the pH is equal to minus log of H plus. Okay, but if the concentration is H plus is less than 10 to the minus 6 molarity, then the contribution of water is also added in the H plus concentration. So we have seen these examples in the previous topic also. If you have not seen, go to the previous lectures and then learn it. So now we will move to one more topic, that is called as the salt. Salt and types of salt. What is salt? What is the meaning of salt? So salt is nothing but it is the product of acid and base. Any acid when react with any base will get salt. Like this is the acid HCl NaOH, and when this combine, we get the product salt, which is one have a positive charge, one is a negative charge. So positive part is called as the basic radical. Positive part is called as the basic radical, and negative part is called as the acidic radical. And in this case, water is also released. There are some other examples in which water is not released, like this one, ammonia plus HCl. It is giving ammonium chloride, but there is no release of water, but they are producing salt. Classification of salts. So let we see the classification of salts. So salts are classified into normally we are classifying 4 types: simple salt, double salt, complex salt, and mixed salt. 4 are simple, double, complex, and mixed salt. What is simple salt? Simple salt again 3 types: normal salt, acidic salt, and basic salt. So these are examples: NaCl, KCl, KNO3, acidic salt, sodium bisulfate and potassium bicarbonate. Basic salt: magnesium hydroxychloride, lead hydroxynitrate, FeOH whole twice Cl. In double salt, alum, Mohr salt, complex salt, K4. You can see here a square bracket. So if anything written in square bracket, there are salts. Mixed salt like CaOCl means this is positive charge, 2 negative charge. This is one compound. Here 2 plus 1, 3 positive charge, magnesium dipositive ammonium. So magnesium ammonium phosphate, sodium potassium sulfate. So these type of salt is called as mixed salt. We will see their definition one by one. Characteristics of salts. So all the salts are ionic compounds and strong electrolytes, except there are some compounds like cadmium bromide and HbCl2 which are weak electrolytes. These salts may be they may taste salty, they may taste sour, they say bitter, it can be bitter also, sour also, salty also, astringent also, sweet also, or tasteless also. Means there is no fixed taste for any salt, it can be anything. So aqueous solution, second point, aqueous solution and melts of salts are conductors of electricity. So they conduct electricity. It should be aqueous solution or their molten states. And the nature of aqueous solutions is maybe neutral, it may be acidic, or it may be alkaline. So that depends on the nature of salts. So we are talking actually salt hydrolysis, means when salt react with the waters. So what is the nature, that we will study under this heading properly. Property of salt solutions are the properties of ions. So whatever the properties we have, that depends on the property of salt solutions present in it. Like silver nitrate solution, so they are giving silver plus nitrate aqueous solution. Like copper dichromate, so copper dichromate is green color, so when it becomes in solution states, so this copper takes the color of blue, and this iron takes the color of orange. So these are the complementary colors. So this is the one of the color, so which is defining the property of the ions present in it. So these are some properties of the salt. Now let us see the classification of salt. So first is simple salts. So they are formed by the neutralization process involving one type of acid or one type of base. So they have one acid, one base. Again, they are classified into following types, subclasses. So we have seen there is normal, acidic and basic salt. So one is the normal salt, that is also called as a neutral salt, and it is obtained by the complete neutralization. One I have mentioned here, complete neutralization. So here just take it in mind, when any acid or base undergo complete neutralization, then this salt is obtained, and such salt do not contain either acidic or replaceable hydrogen. They do not have a replaceable hydrogen, and they do not have a replaceable hydroxyl group also. So this should be absent in the neutral salt. So like we have examples, NaCl, KCl, you can see no hydrogen, no OH, sodium nitrate, potassium nitrate. This is also a salt which it looks like a hydrogen, but if you draw the structure like NaOP, this is the actual structure. So their hydrogen is not, this hydrogen is not replaceable. So this is the poly basic acids. So here this hydrogen not replaceable. This is also a neutral salt. Similarly, NaH2PO3. So this hydrogen also not replaceable. You can see here in this diagram. So this is 2 oxygen, 2 hydrogen. So these hydrogens are not replaceable. That's why these two are also called as a neutral salt. Normally these questions are being asked in the examinations, which are the, so you should not get confused. Acidic salts. These salts are obtained when a polybasic is partially neutralized, and salt contains acidic hydrogen. So the salt must contain acidic hydrogen. So H2SO4, this is a polybasic acid. So undergo with the base, strong base, it becomes acidic. So one hydrogen lost, sodium bisulfate. Then again one more hydrogen lost, then become normal salt. So this is a acidic salt. If this is also lost, then becomes a normal salt. Similarly, polybasic H3PO4. So when react with the sodium hydroxide, it will give you acidic salt. So this is acidic salt. This is a acidic salt. So again reacting, again become acidic salt. But again it will reacting, so this hydrogen removed, this becomes a normal salt. Like we have example, Na sodium bicarbonate, sodium potassium bisulfite, NaH2PO4, sodium oxalate, hydrogen oxalate, potassium hydrogen phosphate. All these are acidic salt. In presence of bases, these salts act as acid. Why? It is very clear, because they have acidic hydrogen, and they cannot exist together with bases in a mixture. So they are acidic hydrogens. If we cannot keep with the bases also. And if you keep bases, they becomes a normal salt. So here, so Na sodium bicarbonate and sodium hydroxide, they cannot be exist together. So if you put it, so this will act as acid, this will act as a base. So this hydrogen will react with the sodium. So we will get the sodium carbonate plus water. So reaction will be like this: sodium carbonate and plus water. So this is our product by reaction. This is never exist together. In aqueous solution, these salts furnish H plus, and so solution is acidic in nature. Already I discussed. So you can have acidic hydrogen, so they will give you H plus ions like this way. Now next is our basic salt. So this is third type of simple salt, that the basic salt. So these salts are obtained when a polyacidic base is partially neutralized, just a reverse of acidic salts, and they contain replaceable hydroxylic group, OH group, and they cannot exist in a mixture containing acid and gives normal salt. Like see here, calcium hydroxide chloride, magnesium hydroxide chloride, bismuth hydroxide. So again this is the polyacidic base. So again reacting with the HCl, it will give you CaOHCl. Again reacting with the HCl with calcium chloride. So this is a basic salt and this is a normal salt. So there is difference between these two. Now next is our buffer salts. So double salts. So these double salts, they are obtained by crystallization from a solution containing two simple salts. Two simple means they are normal salts, and due to presence of constituent of these two simple salts, they are termed as the double salts. So which are the two simple salts? Let us take alums and Mohr salt. We can see this is one salt, two salts, and with some water crystal, water is present as a crystal. So this is the water crystallization. So similarly, Mohr salt is the ferrous ammonium sulfate 6H2O. This is also double sulfate, and these salts are addition compounds, and they are stable only in solid state. Just keep in mind, they are stable in solid state. In aqueous solution, they are not stable. In solutions, these ions are constituting the double salt get separated, and the solution exhibit normal properties of all the ions. Means they will lose their identity in solution state. Let us see example. This is ammonium sulfate, iron sulfate 6H2O. So in the water, so this is double sulfate. When you put in the water, so it becomes ammonium, iron, and sulfate ions in the solutions. So these ions are separated. They will lose their identity in the solution also. And these are formed, we can see here. So this is the iron sulfate, ammonium sulfate with water. So on crystallization, they become the double sulfates. Similarly, potassium sulfate, chromium sulfate in water. So they become here potassium sulfate, chromium sulfate. So this is also a double salt. Potassium sulfate, chromium sulfate, water. So we write like this in 1124. Now we have third salt is your complex salts. What is complex salts? They are also addition compound. Like double salt is addition compound, is addition of two salt, is also addition compound. But it is totally different from the double salt. How it is different? Because they contain complex moiety. What is the meaning of moiety? Moiety means it can be ions or molecules which retains its identity in solid as well as solutions. So in previous cases they are not retaining their identity, but in these cases it is retaining their identity. How this is retaining their identity? Let us see these examples. What is the property of this complex salt? So it is a property of complex part are characteristics. So this complex means this moiety is very characteristics, means their property is very characteristics and totally different from the property of the constituting ions. So from where it is made that the constituting ions, it is totally different. So let us see the examples. KCN plus iron. So these are two salt, normal salt. So on combination they becomes K4FeCN whole 6. This is the bracket 6. You can see here square brackets. So these are the counter ions. Counter ions means which is this is the positive charge, this is the positive charge, and this is the whole is the negative charge. So we can see in despite of this ion, so property of this complex part is very characteristic and totally different from the previous one. We can see their property of iron and the property of cyanide totally different. So in the complex form the property will be very characteristics and different. So again, if you dissolve in water, so like the double sulfate, everything was separated, but it will not separate. This becomes separate, this becomes separate, like this. So this is a complex ion. This will get together. So why we are writing these things? So this you will study under topics known as coordination compounds in 12th class. Similarly, there are so many examples. These type of compounds are called as coordination compounds. One more example is there, copper sulfate with ammonia. So we will get again complex salts. Here again complex part is in positive cationic form. This is in anionic form. This salt is anionic form. This is cationic form. And again this whole behave as an independent unit. Now we are going to see the next salt, that is called mixed salt. What is mixed salt? So they are formed by neutralization of a polybasic acid by more than one base or polyacidic base by more than one acid. What is the meaning? Polybasic acid, what is the meaning? Polyacidic base already we have explained. So this is the polyacidic base, calcium hydroxide. Okay, so this can be OH can be react by the more than one hydrogen. So here HCl, we have two type of acids are there. One is HCl, HOCl. So these two can be replaced by Cl and OCl like this one. 2 OH reacting with the hydrogen. So we will get here 2 molecules of water. 1 H plus OH, 1 H plus OH. Again this 2 OH is replaced by Cl. So this becomes your mixed salt. So this is a what salt? Mixed salt. We can see the mixed salt contains 2 anion. Maybe you can see the charge balance is plus 1, this is minus 1, this is minus 1. So this salt contains equal and opposite charges. So now we have next example, polybasic acid H3PO4. So we can see it reacting with the sodium hydroxide, ammonium hydroxide. So this hydrogen is replaced by water or this hydroxyl ion. So there will be again 2 molecules of waters and we get the salt sodium ammonium HPO4. Similarly, we can react with the H2SO4 reacting with the potassium hydroxide, sodium hydroxide. So there are 2 bases present in the solution. So it will give you sodium potassium sulfate. So mixed salt can furnish more than one cation, which is excluding hydrogen, they have no hydrogen, or more than one anion excluding OH. So we can see here which is dissolved in water. So from this example, it is very clear how they can give one cation, how they can give one anion.